Hello everyone, today I will be going over problems A through D of today's CodeForces round, and will be trying to explain my solutions. As you can see, I mostly spent my time on D because I got stuck. At the end I didn't have time to read E. So let's get into A. In problem A, we were given an array of n integers and we had to find a pair of indices I and j such that for all k the following inequality holds. When looking at this problem, I was trying to figure out what this equality actually means, and pretty quickly I figured out that ai minus ak plus ak minus aj, of course the absolute values of them, it will only be equal to ai minus aj if ak is between ai and aj. We can sort of prove this by trying to look at the two other cases. So if ak is smaller than ai, then ai minus ak plus a k minus aj will definitely be bigger than the absolute difference between ai minus aj, because ai minus ak is already bigger than this. It goes the other way around, so we know that ak must be between ai and aj, so without loss of generality, let's say that ai is smaller or than equal to aj, and we have to find these two indices such that for all k, ai smaller equal ak smaller equal aj. This can be done quite easily by sorting the array. We have to watch out that we store the indices separately. I didn't actually sort the array, I just found the smallest and the largest element. So I can show my code for problem A. It's pretty easy. I have two arrays of two integers. I like to use arrays instead of pairs. And I select the maximum and the minimum value in the array, and I print out their indices. Pretty simple. In problem B, it was once again sort of constructive problem. We were given a list of n integers, and we were given an operation where we can erase an element from this array or this set of integers, and also reduce all other elements by the value of this element. We were also given an integer k, and we had to print yes if we can perform n-1 operations and have the last value in the array be k. For this problem, once again, I just tried thinking about it, tried to see what these operations actually do. And what I found, let's say ABC is our array. First let's remove A, then remove B. When we remove A, we're left with B minus A, C minus A, and D minus A. After this, if we remove any of the remaining elements, for example C minus A, we're gonna be left with, so here it was minus A, here it's minus C minus A, which is gonna be minus C plus A. We're gonna be left with B minus C minus A plus A, and those cancel each other out. that's the important part, that those will always cancel each other out, the last operation that you made. And the other number that we have left is d minus c plus a minus a. And from this, it's pretty obvious that we can only have the last element be k if there exists two indices, I and j, such that ai minus aj equals k. The way we know this, if these two I and j exist, then all we do is remove all the elements besides I and j, and then at last remove aj. And the last element that we will have is ai minus aj. After this, the problem became more of a standard problem. What I did is use a map to store all the numbers that I have in the array. So when I read in the numbers in the array, I just stored it in a map mp of ai equals 1, and then I went over all the integers in the array again, and I was looking if there exists an aj such that ai minus aj equals k. Well, we know that aj must equal ai minus k. I brought aj over here, subtracted k, switch the sides, yeah, this. And after this, I just look in my map if ai minus k exists. If it exists, then I have a solution, otherwise I won't. I can show the code for this too. Here I have two numbers, a minus b equals k, and then ai minus aj equals k, ai minus k equals aj. I check if my map has ai minus k, and I have a boolean flag if that element exists. Okay, moving on to problem C. In this problem, a constructive problem yet again, we were given an array of n integers, and we can make the following operation. Choose an integer x and replace each number of the array by the remainder when dividing that number by x. Yes. So this problem is a bit more tricky. I'll try to explain it. Basically, the first thing I noticed is that if the array doesn't contain the number 1, then I can always find a solution. Basically, let's say it looks like 0, 2, 5, 8, 16. I've intentionally written it in increasing order, and after this all I do is first apply this operation with x equals to 16. All the numbers that are smaller will remain the same because by definition the largest number will be larger than all the other numbers, and the remainder that the other numbers give will be themselves, and 16 will be turned into 0. And then I can do this operation from largest to smallest, and I'll have a solution which is 0, 0, 0, 0. After this, and the problem with this is if there's a 1, we cannot do this operation with a 1 because it says in the problem explicitly that x is bigger than or equal to 2. So if there's a 1, we have to find a solution where we make all of the elements of the array equal to 1. And I tried a couple of examples and I found that well, first it can be done if we try the same type of strategy, but instead of doing the remainder with the biggest number, we do x equals to 15. And then this will be turned into 1 and we move on to the next one. Of course, the problem with this is if I also have 15 in the array, 15, 16, if I do the operation with x equals to 15, we're gonna be left with a 0 and a 1. And if I have a 0, then I cannot turn that into a 1. So that's gonna be a problem. I wrote my code to check if the difference between each neighboring element is bigger than 1. If it's bigger than 1, then I can solve it, and if it's not bigger than 1, then I found that I cannot solve it. I don't have like a formal proof for that, but I've tried some examples and it seemed to be the case. So I can also show code for this. I read in the integers, I erased all duplicates because duplicates don't really matter in this problem. I eliminated the edge case where n equals to 1. After that, if there's no 1 in the array, then I'm good, because I can make them all zeros. If there is 1, there is 1 in the array, then I went through the array and looked at all neighboring elements. If all of them had a difference bigger than 1, then OK remained true, other than in the other case I flipped it to false. So far this passed. I will be looking at the system tests because I'm kind of scared of D. It's still in queue, alright. D was definitely more difficult. But I'll try to explain it. So I was in the midst of explaining problem D when I realized that my solution for problem D didn't pass the system tests, which is sort of unfortunate, but that means that I don't have to explain my solution because clearly it's wrong. Overall, I didn't think that B and C were very good problems. Well, that's because they're constructive and I don't enjoy constructive problems much. I did enjoy thinking about D. Yeah, so I hope this video was helpful to some people. I'll be trying to post more videos like this, teaching people how to solve these problems. I am looking forward to everyone's feedback, so please comment and do all the good things. Alright, bye.